Hi everyone, we're going to evaluate the integral by letting x equal 2 sine of theta. And we're going to sketch and label the associated right triangle. So here we have this, and it said let x equal 2 sine of theta. And therefore our derivative of x equals 2 cosine of theta d theta. So since we're going to do that, we're going to just look at this piece right here. If you just look at that and we separate it out, you have 4 minus x squared is going to equal the square root of 4 minus, and I'm substituting in this, so that's going to be 4. If I square this, so you're squaring it here, you're going to get 4 sine squared theta, which breaks up to square root of 4 times 1 minus sine squared theta. You can bring out the 4, that's going to be 2. And this is going to be cosine squared. That's your identity. And so what you're going to get is this is going to equal 2. And square root of a square is just going to be absolute value of cosine of theta. Now our interval, you look over here, we're doing sine, is in between negative pi over 2 and pi over 2. Looks like I didn't put the negatives in there, so I have to fix that. All right, so that means cosine, that's quadrants 1 and 4. And cosine's already positive, so that means we can take away the absolute values. So basically we have this equals just 2 cosine of theta. Now we're going to use substitution. So thus we have dx equals this. So let's just write that down. That's just going to be 2 cosine theta. And I'll put the d theta here. I'll just put it here for now. All right. And then my x squared is just going to be 4 sine squared theta. And then my x, or my 4, this part we already did. And that is just 2, it's right here, 2 cosine of theta. And I prefer to put this d theta out to the side here. All right. Now, simplifying that, we're going to get 1/4. This is 1/4. These two cancel. Well, these two cancel. So we get 1/4, and then we're going to have 1 divided by sine squared theta, and that's going to equal 1/4 times the integral of cosecant squared theta d theta here. All right. So now that that's why we like to use these table of trigonometric substitutions. So what we have is 1/4 integral of cosecant squared theta d theta. Now recall our x, we're going to have to substitute all this back in because it's an indefinite integral. Our x was 2 sine of theta. So our sine of theta equals x divided by 2. And they said draw the triangle that corresponds to this. So I'm going to draw a right triangle, let that be theta. There's your right angle there. So sine of this is, sine is opposite over hypotenuse. So opposite is going to be x. Hypotenuse is going to be 2. And to get this length here, the adjacent side, you're going to use the Pythagorean theorem. So you're going to get x squared plus, let's call it y squared equals 2. So you're going to get 2 equals 2 squared. So basically you get y squared equals 4 minus x squared. We want positive, so y, or this length, is going to be square root of 4 minus x squared. So this is square root of 4 minus x squared, which was what was in our original problem. So now that we have this here, we can look at our derivative, and we know that the antiderivative of cosecant squared is negative cotan of theta plus c. But we can't just leave it like that because we started with x, not theta. So let's look at cotan of theta. If you look at cotan of theta, we know that cotan of theta equals adjacent over opposite. So this is going to be negative 1/4, and adjacent is going to be square root of 4 minus x squared, and opposite is over x. And then that would be plus c. Or you can simply write it as negative square root of 4 minus x squared. Go ahead and multiply these two. Divide it by 4x plus c. And that simplifies it a little better. And that's it. Thank you. Have a nice day. Bye-bye.